In this video, we're going to look at an improper integral where the integrand is unbounded on a closed interval. So the big issue here is 2 is a vertical asymptote for this rational function that we have as our integrand. And 2 is actually in the middle of our interval. Sometimes you'll see it's just one endpoint or the other. If it's in the middle, what we have to do first, before we rewrite this using limits and making it a proper integral, we have to break this up at that point where the discontinuity happens. So we're going to go from 0 to 2 of 2 over x minus 2 dx plus 2 to 4 of 2 over x minus 2 dx. And we're going to calculate each of these. If at least one of them diverges, the whole thing diverges. They both must converge in order for this original to converge. Now what we're going to do is write each of these as a proper integral with a limit. So the first one, I'm going to go from 0 to b of 2 over x minus 2 dx. And what I'm going to do is I'm going to do the limit as b goes to 2, and now it's going to head to 2 from inside the interval. So if you can imagine being, here's 2, here's 0, we're in this interval, we are approaching 2 from the left. So that's how you decide which direction you want to approach your limit from. As you can imagine, this one's going to be pretty similar. I'm going to use a, because I don't want to use the same letter as before, because it's a slightly different limit, because we're doing one-sided limit. The integrand's the same. And it's going to be the limit as a approaches 2 now from the right, because we're going in between. It's as if we're starting in between 2 and 4 and heading towards 2. So we'd be coming in from the right. One of the nice things is both of these have the same antiderivative. So that does save a little bit on work time. So we have limit as b goes to 2 from the right. The antiderivative here, I'm not going to spend a lot of time on this. It's 2 natural log of the absolute value of x minus 2 as we go from 0 to b. Plus, over here, limit as a goes to 2 from the right of 2 times the natural log of absolute value of x minus 2 from a to 4. So we're going to plug in our limits. We're going to plug in our limits of integration, then we're going to take the limits. I know we're using limits in 2 different ways, so I try and keep that from getting too confusing. Limit as b goes to 2 from the right. This is going to be 2 ln of the absolute value of b minus 2 minus 2 ln absolute value of 0 minus 2. Now you can see why we need those absolute values in there. Over here, plus, it's going to be very similar. Limit as a goes to 2 from the right, and we're going to have 2 natural log of absolute value of 4 minus 2 minus, and maybe to show that that's with that limit, I'll use some parentheses there to make that a little more obvious. 2 natural log of a minus 2. Alright, some of this will be very quick and straightforward, and then we'll talk about the limits. So here, I'm going to rewrite this. I'm going to rewrite it as 2 times the limit as b goes to 2 from the right of the natural log of absolute value of b minus 2. This part will not depend on the limit. It doesn't depend on b. This is 0 minus 2. It's negative 2. Absolute value is 2. So minus 2 natural log of 2. Very similarly, 4 minus 2 is 2. Absolute value 2 is 2. 2 ln of 2. It does not depend on a. So 2 ln of 2. So you can already see that these are going to cancel. Minus 2 times, now this part we will need to know the limit on. A goes to 2 from the right of natural log of a minus 2. So we have 2 limits we need to calculate. One for the first integral, one for the second. And probably to make this a little bit easier to see is if we knew what the graph of y equals natural log of absolute value of x minus 2 looks like. And this would be something you could do with a graphing calculator, or you could graph it on your computer. What happens is we are going to have a vertical asymptote at 2. We're going to have zeros at both 3 and negative 1. And our graph is going to come in like so. So, right here, as we go to 2 from the right, we go to negative infinity. At this point, we're done. This improper integral diverges, the whole thing diverges. So we can say diverges. But just because we already have the work done, as we go to 2 from the right, notice the same thing's going to happen. This is going to go to negative infinity. So actually both of them in this particular case diverge. But we only really needed to show one. At that point we can say the whole thing diverges and we're finished with this improper integral.